I'm just going to trust that that's working. Let me share my screen. Let me check here first. So in the chat, let's see. When you say it keeps pushing back the date, what do you mean? Like, is it allowing you temporary access? As long as you can access the materials, or that if you bought it a long time ago and it hasn't come, your access code, I would encourage you to contact two sources, the Morehouse bookstore and the mathematics department chair, Dr. Clark, right? So you can make an email, just make an email explaining that, and maybe you can CC me on it as well. But basically explain the situation, because that's something that they have to. The main thing right now is for you to gain full access to especially if you've already paid for it. And then once you gain full access, we'll fix it on the back end. But first, you got to focus on gaining full access. So the Morehouse bookstore and the mathematics department chair, CC me on it and just explain what's going on. And then once we figure out, we get to the bottom of it, then we can fix everything on the back end. Okay, so let me start by sharing my screen. Start the broadcast. And start here. All right, so greetings, scholars. No real announcements. Hope everyone had a nice fall break, right? So we had Monday off. I did show up here on Monday at 9. I was like, where is everybody? And then it clicked in my mind. I was like, oh, I think we're on fall break. So I went and checked, and sure enough, we were on fall break. So right now, exam 2 is available. We can do one of two things. I mean, I'm open to kind of working problem sets, but if you guys don't really want to do that, we don't have to. I can just make myself available for questions. So I don't know, I'm trying to fill it out. I guess we can look at a few questions. Maybe we'll just kind of play it by ear. Okay, so let's hop over to my math lab. And again, exam 2 should be available right now. So you should access it. It's due, I think, this Sunday. The due date is on the left, October 8th. And it says sections 1.4 to 1.6, but again, you can't really do that without using the previous sections as well. So we don't have a lot of time. So I'm gonna jump around. Hey, Google, give me a random number between 4 and 6.
5.
I guess that makes sense. Combining functions. Let's spend at least 10 minutes on each section. Let's just do 10 minutes. Hey, Google, set a timer for 10 minutes.
Okay, 10 minutes. And that's starting now.
Hey, Google, give me a random number between 1 and 23.
17.
Okay, we'll start with 17. And I'm thinking at least 10 minutes, give or take, on each section, and that'll be enough for the day. Oh, let's zoom out so you guys can see this. Let me zoom in. Okay, so this comes from section 1.4, question 55. Given this G, find the average rate of change of the function as x changes from -6 to 5, right? So for this course, whenever you see average rate of change, it basically just means find the slope between the 2 points, right? So they gave us 2 different x values. We're going to find the corresponding y values, and then find the slope between the 2 points. All right, that's essentially what's going on here. So what I'm going to do, I'm going to put this function into my function editor over here. I'm going to put 2x squared minus 5, 2x squared minus 5. So that's G. And then I just want to say y or G2 minus G1 over x2 minus x1, right? So first I'm going to call on that function. Actually, I want to isolate the numerator. I'm going to call on the function. Okay. And I want it, if my x2, I want to evaluate the function when x is 5. Then I'm going to say minus, I want to call on that function again and evaluate the function when x is -6. All right. So that's like me saying my G2 minus my G1. I put all of that in parentheses, so it does that first. Then I'm going to say divided by, now I want to say x2 minus x1. So that's going to be 5 minus parentheses, I'm going to say negative 6. And close off the denominator. And so basically all we're doing is finding the slope between the 2 points. And we get a slope of negative 2. So I'm just going to submit negative 2 and go with that. Okay, so I feel like there should be questions, but if you do have questions, comments, or concerns, feel free to unmute yourself to get my attention and we can talk about it. Also, I am monitoring the chat. Hey, Google, give me a random number between 1 and 23.
9.
Okay, let's do 9. Determine algebraically whether the given function is even, odd, or neither, right? So if we're doing even, odd, or neither, the main takeaway is that we replace each x with negative x, we simplify, and then we interpret the results. After doing that process, after simplifying, if we get back to the original, so that means f of negative x equals f of x, that means the function is even, which is y-axis symmetry. If after simplifying, if we get a negative times the original, then that means f of negative x equals a negative times f of x. That means the function is odd and we have origin symmetry. All right. Let me see. Okay, so it's only there. I'm going to say that I think this is neither. Like if we replace each x, I'm trying not to write it out just because I'm being lazy. But if we replace each x with negative x, the x squared goes back to the original. The x to the 4 goes back to the original. But then that negative 4x becomes positive, right? Which is not the original. And if we try to factor out a negative, let me see. If we factor out a negative, that'll become negative. And that'll become negative, right? Even if we factor out a negative, we still can't get to some form of the original. So I think this is an example of something that's neither even nor odd. Again, I just didn't write it out. I just kind of did it mentally. But again, the whole idea here, the takeaway, we're just verifying the definitions of a function being even or a function being odd. The definition of a function being even, f of negative x equals the original. And then the definition of a function being odd, f of negative x equals a negative times the original. Okay. Hey, Google, give me a random number between 1 and 23.
21.
Let's see. So the graph to the right shows a particle moving on a coordinate line with a velocity v equals f of t at time t seconds. Find the domain of the velocity function. All right. So the domain. In a graphical sense, the domain is the very left to the very right. If we were to take this image and squish it vertically onto the x-axis, all right, that's called the projection. And then wherever that squished image touches the x-axis, that's our domain, all right? So you should be able to visualize if we were to smush this image down to the x-axis, it's such an x-axis as x goes from 0 to what is that, like 23? So type your answer in interval notation. It looks like it's 0 to 23 inclusive. So 0, 23, hopefully I'm doing that right. I use square brackets because it was defined at 0 and 23. So we wanted to include those endpoints. The particle's motion is tracked from 0 to 23 seconds. Takes on all velocities. Motion is tracked, no. It's tracked from 0 to 23 seconds, this one. Hey, Google, give me a random number between 1 and 23.
23.
1 and 3. So, there's supposed to be this emergency broadcast alert today around 2:22. I would encourage you to have your phones off, literally turned off, and be away from them and other phones from 2 to 4, just for a couple of hours. Just turn it off, put it away, go do something else. There's some kooky, sinister stuff that's supposed to happen as a result of this emergency broadcast. I don't know if it's true or not, but I feel like it doesn't hurt anything to turn your phone off for a couple of hours from 2 to 4, right? I'm more than likely going to let the students know, look, guys, we'll come back. We're going to have to meet next time. I'll just meet with them for a hot second and let them go because you know, it's really weird. And it's like, is that real? I was like, well, the remedy is, just turn everything off and leave it, step away from it for like a couple of hours. I was like, well, I can do that. So, okay, anywho. So this one says, Kara's Custom Tees experience fixed cost of $400 and variable cost of $2 a shirt. Write an equation that can be used to determine the total expenses encountered by Kara's Custom Tees. Let X be the number of shirts to C. Then calculate the cost of producing 7 shirts. Okay, so we want a cost function. This seems linear, right? You got a fixed cost of $400 plus $2 a shirt, right? So it looks like it's just going to be 400 plus 2x, right? I think that one's not too bad. 400 plus 2x. Okay. The cost of producing 7 shirts, all right? So then we let X be 7. 7 times 2 is 14, plus 400 is $414. All right. So then that's what it costs. Do they have her? Is that it? I wanted to do some more. It was vested in the question. I was like, well, how does she turn a profit? If it costs her $414 to produce 2 shirts, how much is she selling them for, and how many does she need to sell in order to break even and turn a profit? Hey, Google, give me a random number between 1 and 23.
Here's a random number, 13.
Okay, let me check something. Bell Williams, come on. Cool. Let them in. Cool. All right. 13, all right? Where's my timer? Hey, Google, how much time is left on the timer?
You've got 1 minute and 2 seconds to go.
Hey, Google, stop the timer.
No problem. Consider the timer canceled.
Hey, Google, set a timer for 14 minutes.
Okay, 14 minutes. Starting now.
So given this f of x, we're asked to find f of 1. Okay, I think we need to change it. Well, let me finish this. Maybe, okay. So this is called the piecewise function. Basically, you graph each line like normal, but then you erase the part that you don't need. So for instance, the first line applies when x is greater than or equal to 3. So if we put a vertical dashed line at x equals 3, it's just going to be the graph of y equals x, but we're going to keep the right-hand side of the graph with a closed circle when x is 3. And then the second one is a horizontal line with y equals to 3, but we only keep the left-hand side, right? So we keep the portion that's left of 3 with an open circle. If these two overlap, which I think they do, then the closed circle fills in the open circle. So when x is 1, that means we're going to use line 2. That means the output is always 3 for that one. Okay. When x is 3, we're going to use line 2, and then the output there is also 3. Okay. Yeah, that's fine. Okay. Yeah, that one's all okay. That's fine. When x is 6, we're going to use line 1. So that output is going to be 6. I think we said left of 3 is a flat horizontal line, and then right of 3 is a diagonal line. And I think they do overlap. And the only one that does that properly is B. Okay. Let's go to the next section. So the timer's already going. Look at this. Here it is. That was 1-4. Let's spend some time on 1-5. Yeah, I'm glad I did this. Like, just as a review, because again, exam 2 is available right now. You can work on it right now. If you have questions from the exam, you can ask me. Like, this is the best time. I think the exam is due, I think it's this Sunday. Hey, Google, give me a random number between 1 and 20.
17.
Let's see, 17. So let's do 19 since we haven't done 19. Oh man. Okay. So this comes from section 1.5, question 63. Let f be a function that associates the employee number of each employee of a corporation with his or her annual salary, f of x in dollars. So x is the number, f of x is the salary. Suppose each employee was awarded $700 across the board raise and an additional 6% of his or her increased salary. Write a function p of x to describe the new salary, right? So we're taking their salary and doing a flat increase of $700. So it creates a new salary. Then from that new salary, we're going to increase it an additional 6%, right? Okay. So we can say f of x plus 700 plus 700. And then we want to increase this by 6%. So like if we wanted to be 6% more, that means we're going to say 100% plus 6%. So we want to finish with 106%. So what we're going to do is say this result times 1.06, right? So that's increasing it by 6%. We need parentheses, and they probably want us to simplify. Let me see if I can see that. Type an expression in slope-intercept form. Okay, so if we distribute that 1.06, we're going to have 1.06 times f of x and then it's going to be plus whatever 1.06 times 700 is. Hey, Google, what's 1.06 times 700?
1.06 times 700 is 742.
Okay. Let me get rid of this other stuff. So I kind of was basically taking notes here. Again, I took their salary, I increased it by 700, and then I took that new salary and increased it by 6% by multiplying by 1.06. Then I distributed the 1.06 to give us what we see on the right. So let me get rid of this left part. I'm just going to hit enter. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 16.
Okay. Hey, thank you. Good to know that. I use the graph. Let me zoom out so you guys can see this. So use the graph of f of x shown below to graph the function g. So with g, we did a transformation where we multiplied the inside by a number between 0 and 1. So multiplying the inside causes a horizontal change and is generally the reverse of our intuition. So since we multiply by a small number, it should get bigger horizontally, right? It does the reverse. So it should stretch horizontally by a factor of 2. Okay. I think the only one that stretched, the 4 should go to 8. It looks like the only one that stretched horizontally is D. Okay. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 7.
Okay, so after 7, let's do 12 since we haven't done 12. Where the let me zoom in a little bit. Okay. So write the function whose graph is this graph, but it's shifted left 7 units, right? So again, if we're moving side to side, that means we're doing God bless me. If we're moving side to side, that means we're doing an inside manipulation, right? Because inside manipulations cause a horizontal change, and it's typically the reverse of our intuition. So if we're going left 7 units, which is into the negative x direction, so instead of subtracting 7, we need to add 7 on the inside to have that effect, right? So then this is going to be absolute value. I think it's x plus 7. Hey, Google, give me a random number between 1 and 20.
5.
Okay. The next one, I guess, is 14. Let's do 14. Timer should be just about ready to go off. I'm checking you guys in Zoom. There's something in the chat. Let me get the student. And in the chat, let's see. First question on the exam. So I think the first question changes for each student. If you are working on it right now, you can screenshot it, email it to me, get my attention. I'll pull it up and we can talk about it, right? Because it's going to be different for each student. If you just screenshot it, send it to me in an email, and I'll pull it up, or you can put it in the chat, I think. But just make it available, and then I'll pull it up and we can talk about it. And just let me know once you've sent it. Hopefully that should be a free point, right? If we should get it right. The chances of us getting it correct together are drastically increased, right? Still, it's still not a guarantee. We're definitely still getting wrong sometimes, but the chances of getting it right are drastically improved. Okay, I think this is the next one. Write an equation for a function whose graph fits the description given below. The graph of f of x is x cubed, shifted 2 units left, stretched vertically by a factor of 3, reflected in the y-axis, and shifted 6 units up. Okay. What is the equation of the described function g? Okay. So maybe I should zoom out. Let me see. Shifted 2 units left. So we need to add 2 on the inside. So we're going to have x plus 2 on the inside. Stretched vertically by a factor of 3. So 3 times x plus 2. And flipped horizontally. Okay. Okay, I think I got it. So I know we have this 3 parentheses. X, I think it was plus 2 on the inside. Okay. To the power of 3. So that's going to the power of 3. And then we said it flipped horizontally. So the way the book kind of captures that, they just put a negative right here. And that's pretty much it. I'm going to go with this. All right, it's the negative. I know that's the one. Let me see. 2 units left. That's good. Stretch vertically by a factor and reflected in the y. Oh, we forgot to shift it 6 units up. So there's a plus 6 on the outside. That's why I was trying to change the view, but that's fine. Plus 6. I was nervous about that negative, but I think this looks better. We forgot the plus 6. Let's go with this. God is good, right? Yeah. So that's the way that they capture flipping horizontally. It's a little bit trippy, but yeah, that's how the textbook has done that part. Okay. Let me check the chat. See if there's students sent it. I don't see anything in the chat. Okay. All right. Well, I'm going to keep going. Let me see. Let me check my email, which I just generally don't do. Let me see. Did he send it? I don't see anything. Okay. That's, who's this? Oh, look at this. Okay. There's a fair today. Okay. So there's a fair. It says this is encouraged. It says this is a gentle reminder to share with your faculty and students that the AUC Graduate and Professional School Fair is tomorrow, Wednesday, October 4th. From 3 to 6, this event will take place in the Wellness Center at Spelman College. Please see the attached electronic flyers. Graduate and Professional Fair. Let me see if I can pull a copy of this. These are several. How do I pull all of these? Save through images. And if I go here, all photos, select 1, 2, and 3, share. Can I just copy the photos? I'm going to try to paste some photos into the chat. Hey, Google, stop. Chat. Okay. Let me select. Share. There we go. Felt like that was going to happen. I'm trying to get these flyers to you guys. Where else can I put them? Let me get this up. Right here. I guess we can just do like this. Share. That would be nice if I can put it in the chat. Can I add a photo? Chat. Give me just a moment. Let me stop. Ooh, that's a weird sound. That's fine. Is it not gonna let me do it? That sucks. Okay. Well, I know this works. This is what I was trying to avoid. I didn't want to do it this way that I'm about to do it. Photos. Because I still wanted to use my screen. These guys. More. Can I just save them? What time is it? Save. Save. Let's save. Okay. I'm trying to think of where I can share it somewhere else. Okay, I got another option. I'm gonna put it into Box. I'll put it in the handout section. Since I can get this open. So fall, this one, handouts. No add. Nope. Okay, let's go here. Oh, this is a pain. It's taking way longer than I wanted it to, but that's fine. I think I got something that's gonna work. And this is important. Like, this is good stuff. Stuff that, you know, you guys can definitely use. Okay, share. Here it is. Share to Box. Okay, and the destination, fall, traditional, College Algebra 1. I'm putting it into the handout section, and we can put it there. Okay. Upload. Okay. And Missing. So I just loaded some photos, and I guess I'll pull them up for a hot second. But if you want a copy of it, it is located in our box folder. You can access it on Blackboard. Let me share. Oh, I guess I gotta do that. Let me see. Let me see if I share photos. So when I got my emails, I got these three. It's not going to display all the way that I would like, but these are three different flyers. You can either screenshot this, and you should be able to scroll and see all three of these guys. But I think they're probably the same thing. It's just three different flyers of the same thing. So grad school can help you stand out, explore your options. So this, if you wanted to quickly screenshot these, this is today from 3 to 6. I think this is a really good event. It's a good idea to attend. Grad school. I don't really want to discourage anybody from going to grad school, because it positions you for power, and it's like you definitely want to go all the way, get a professional degree, and finish. The key is you need to finish. Without finishing, then it gets kind of dicey until you do finish. She looks familiar. He looks like Wayne Brady. He looks like Wayne Brady. They all look so familiar, like I've seen them before. Anywho, I just wanted you guys to see that so you can screenshot it. We only have I didn't really want to keep you more than about 5 more minutes. We didn't get a chance to get through 1.6, and I know somebody requested question 1, but I don't think he ever sent it. So I think we're just going to go ahead and stop there. Are there any burning questions before we go our separate ways, guys? Going once, going twice. Okay. So if there aren't any burning questions, we're actually going to end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. Remember, turn your phones off from 2 to 4 today, and we'll meet back next week, same time, same place. And take care, guys. Peace.